this new video where we will be installing the single node OpenShift 4 cluster on my M1 Pro MacBook. So basically the cluster is based on ARM architecture. So even let me show you the chip for my MacBook. It is M1 Pro. So definitely there are some prerequisites for installing this ARM-based SNO cluster. So the first one is definitely the virtualization software, which is VMware Fusion that I will be using, and it is already pre-installed. And one is like you have to set up a DNS server. So whenever we install any OCP4 cluster, the API URL is there, like for the OCP cluster to handle the API request whenever you run OC commands and all. So the API URL format is like API dot your cluster name dot test domain name. So that URL must be pointing to your single node OpenShift 4 cluster virtual machine IP address. So for that particular thing, like if you want to learn how you can set up a DNS server and modify the VMware Fusion Pro DHCP configuration as well. So anytime you create a new virtual machine, the DNS query will go to your custom DNS server every time. So I will provide this particular YouTube video link in the description, and even if you want to get all the steps, like all the commands that were executed in this video to set up the DNS server and all, you can find in this particular blog post as well. And also if you want to know from where you can download the VMware Fusion for free and install it on your Apple Silicon based MacBook, you can refer to this particular blog post as well. Okay, and apart from this, there is one more prerequisite to install the SNO cluster on the ARM-based MacBook, which is to install the Podman. So on my terminal, like right now, I can show you the Podman is already installed. So basically, if you are not having Podman installed on your MacBook, so first of all, you need to install the Homebrew, and which is nothing but a package manager for macOS. Just like on Linux, we have apt yum package manager and many other type of package managers. For the macOS, the Homebrew can be used. So basically, this is the command, and with this, you can install a Homebrew package manager. Once you install it, you can run brew install podman. So it will install the podman on your Mac machine. On my machine, it's already installed. And after this, you have to execute a few more commands, which is like podman machine init. So this will just create a podman machine so that you can run the containers and pull the images and those sort of things. So I'm just running podman machine init. So the machine is created now, and I will start the machine as well. Podman machine start. So even this won't take that much time. Okay, so the machine started now. Okay, apart from this, in terms of DNS server, so let me show you my DNS server which is running in this Fedora virtual machine. So let me open the terminal for this virtual machine. Let me become the root user. Okay, so here I have already configured the DNS mask service for like example.com domain. So any DNS query that comes for example.com, like it can be test.example.com or api.ayush.example.com, which is like my cluster API URL. It will always answer with this particular IP address .131. So even like let me get the IP address for this machine. It is this one, and let me try to do NS lookup for my API URL, which is api.ayush.example.com, and let's try to do NS lookup on the DNS server. If you see, it's giving answer with this 131. This is the forward lookup, but we have to configure the reverse lookup as well, which is very necessary because that's how your virtual machine for SNO cluster will get the hostname as well. So for doing that, like the forward lookup is working, like whenever we do NS lookup for hostname, it's giving the IP address, and when we do the NS lookup on the IP address, so let's see what we will get. Yeah, it's giving the same thing, api.ayush.example.com. That's what we need. And how this can be configured, like this can be configured in cat etc host. So basically your DNS mask will provide the forward DNS lookup with the dnsmask.conf file, and for the reverse lookup you have to make the entries in etc host file of your DNS server. So this everything is explained in that particular YouTube video for configuring the DNS servers and all. So let's move to, okay, before moving with the installation of SNO cluster, one more thing. On my DNS server right now, my example.com domain is pointing to .131 IP address, and I'm not sure the SNO virtual machine that we will create will be having this IP address or not. So if the IP address is different for that machine, once we create it, we will know. Then we have to modify this configuration, and which won't be that much complex, and we can do it within a few seconds when the machine boots up. Okay, so now let's move to official documentation of OpenShift, docs.openshift.com, and here under the OpenShift container platform we will select the latest version 4.16. So here we will go to installing section, and we will select installing on single node, installing OpenShift on a single node, and here multiple methods are given, whether you want to install a cluster with assisted installer or whether you want to go with AWS, GCP, Azure. But here we are creating the cluster with the help of virtual machine, like completely manual method, like bare metal UPI we can say. So that's why we will scroll down and we will go with this particular method, installing single node OpenShift manually. And here it's mentioned like some of the prerequisites are there, which is like networking, DNS and DHCP, which is already covered from the VMware Fusion Fusion side, and the DNS is already configured. Okay, so now we will go with the steps one by one. So first of all, what I will do, I will go to my terminal and I will create a new directory first, where we will be creating all the files and all sort of stuffs related to the SNO cluster, and I will switch to this directory now. And now first command, OCP version, so we will go with latest 4.16 version. The architecture, because my host architecture, like basically my MacBook architecture is ARM architecture, so that's why I'm exporting this variable ARM64. All the details are given here. And now in the third and fourth step, we need to download the binaries for OC and OpenShift install. So if you notice, these links are pointing to the Linux based binaries, but we need to go with the ARM architecture based binaries for Mac machine, and I'm already having those links handy with me, and I will definitely provide those uh, in this particular video description in the form of blog post. So let me first of all download the binaries, like basically those are in the tar format. So we need to untar those files. So first of all, we are downloading this OC binary of ARM architecture valid for the Mac, and I will just untar this file as well. We have already downloaded it. So yeah, okay. After untarring it, we are having the OC binary. Let's check the version. So the version is latest 4.16.8. Similarly, we will download the tar file for OpenShift install program. So it's around 488 MB in size, so it might take a few minutes. Okay, so after the download completes, we can enter that file as well. And now we have we have OpenShift installed binary as well, and we can check the version for it. So yeah, it's also 4.16.8, and the most important thing, the release architecture is ARM64 for this binary. Okay, now back to the documentation. So the third and fourth steps are completed. We have to go with the fifth step, where we will be exporting this particular environment variable uh, to fetch the ISO for our virtual machine based on the ARM architecture. So yeah, in this command basically we are getting that value from the OpenShift installed binary output itself, where we are passing multiple parameters, and we can also check what exactly this environment variable contains now. So if you see, it's having the download link for that ISO file. Now moving to sixth step, where we need to download the ISO. So meanwhile this ISO downloads, which is around 1 GB in size, we can check a few other things. So here in the seventh step, we are creating an install config YAML file, where we have to modify a few things. So first of all, the base domain. In my case, it's example.com, as I have shown you earlier on my DNS server machine. Then the cluster name, which is Ayush, and here in the installation disk path, we have to provide the correct virtual disk path for your virtual machine where the operating system gets installed. So you can identify what will be the disk path very easily by just spinning up any sample virtual machine on VMware Fusion. So right now I'm having my DNS server running already, like on a virtual machine Fedora 40. So what I can do, I can run app disk -l, so it will list all the disk available like for this virtual machine. So right now I'm only having single disk for this virtual machine, and its name is /dev nvme0n1, and rest of the are partitions. So we have to specify this particular name because for any virtual machine I create, the primary disk name will be this only. And after this, the pull secret, which is required for pulling the container images. So the pull secret can be obtained from this particular website, console.reddit.com/openshift/create cloud. So here, instead of cloud, we will go to the local section, and by the way, you have to register on this website, and a valid account is needed to get the pull secret. And under the local section, you can copy the pull secret. And apart from the pull secret, the SSH key part is not mandatory, but it's better if we specify this, because here we will be giving the public key content which get copied to your to your SNO machine, so that you can SSH to that machine in case any troubleshooting is required or you need to check a few things. So yeah, back to my terminal. So ISO is already downloaded now, and let's create a install config file. So let's start with the install config YAML file, and first of all we will copy the sample install config YAML data as it is, and let's modify it. So first of all, the base domain, which is example.com, the cluster name, which is Ayush, the installation disk, which is in my case will be dev nvme0n1. And before testing the full secret, let's create the SSH key pair for SNO cluster. So I will open a new tab in my terminal, and I will run SSH keygen command to create a key pair. So I will save it with a different name, so it will be SNO. Okay, and now I'm having basically two files with the name SNO. So one is the public key and one is the private key. So we want the content of the public key. So let's get the content of the public key, copy those, and we can paste it here. And now we have to provide the full secret, and the full secret needs to be copied inside these single quotes. So yeah, I can copy the full secret, paste it here for pulling the container images. Let's save the install config YAML file. Back to the documentation, and in the documentation we need to create a directory. Okay, we have created a new directory now, and as per the documentation we have to move this install config YAML file into that new directory now. After doing that, we just need to create the single node ignition config using the OpenShift install binary and the install config YAML we created, and we are pointing to the same directory we created right now. So once the ignition is created, we can perform the 9th step, and here if you notice in this particular command alias CoreOS installer, podman run command is executed. That's why it was a prerequisite to have the podman configured already on your MacBook. So now we can run this command as it is, and the last command, which is basically with this particular CoreOS installer, we are modifying our rhCoreOS live ISO that we downloaded. Like, we are embedding the ignition config we just created into that ISO. So whenever the machine boots up, it will bootstrap the cluster with all the details we specified in our install config YAML file. So after running this command, it will pull the container image. So it depends on your network bandwidth and all. Okay, after this we got our actual ISO with which we will be putting the virtual machines. So let's create a new virtual machine first. And okay, so new virtual machine, create a custom virtual machine, continue. And the operating system for this virtual machine will be based on Red Hat Enterprise Linux 9 64-bit ARM. You can click on continue, continue. Customize the settings. We can give the virtual machine name here, which is OCP4 SNO ARM. Save it. We have to modify a few things. So processors and memory, I will create 4 processor cores, and I will give it around 16 GB of memory. Okay, and in the hard disk I will give it around 50 GB of space. Apply. And for the CD DVD configuration, we need to specify that RH course live ISO that we just uh, created, like with the proper modifications, ignitions and all. And after this, just verify the network adapter. We need to use the same network adapter where uh, like which is getting used by our DNS server virtual machine. So the DNS queries will work. After this, we can boot our virtual machine. So once this machine boots up, we have to verify whether the IP address is the same or not for our API. So the IP address for this virtual machine is .131. Let's see what we are having here. The cat etc host, it's 131. NS lookup, copy. Yep, 131 it is. Okay, and now we can monitor this particular. Okay, so we can SSH to this virtual machine for now from another tab. So 131, and the private SSH key is this one, SNO. I will specify yes, and once you SSH, you will see this command, journal cd command. We can run it to monitor the installation process. So it put the images, it's rendering the manifest. So basically, it's writing all those YAML files with which the resource will get created in the cluster. So right now, it's trying to bring up the temporary control plane, so the actual cluster can be bootstrapped. So it definitely takes time. And if you see here, the machine hostname is also set now api.ayush.example.com due to those DNS configuration, basically the reverse DNS lookup. So during this process, this particular virtual machine will get rebooted twice. So first, it will bring up the temporary control plane. After bringing the temporary control plane, it will reboot. And once the machine comes up, it will again perform uh, another process. Basically, RPM OST service runs. Once that service also completes, the machine will reboot, and finally, the containers, like everything, like control plane, your router ports, everything will start coming up one by one. So yeah, here if you see, uh, it's trying to bring up the temporary control plane here. Yep, starting cluster bootstrap. So now starting temporary control plane, still waiting for Kubernetes API to come up. Okay, so throughout this process now, it will be creating lots of objects in this particular cluster, like temporary control plane, I should say. And throughout these logs, you will see multiple errors. If you see failed to create this particular object, so there will be a lot of errors like this, and you can definitely ignore this, because at the end, it will eventually end up creating all the necessary resource. So these errors are expected throughout this cluster creation. And once the cluster bootstrap completes, it will tear down the temporary control plane at the end to restart the machine. So we will see those log messages as well once the bootstrap complete. Okay, so now if you see the bootstrap process completed and it's tearing down that temporary control plane. So here's those messages tearing down temporary bootstrap control plane. Okay, and now we can hit Control C and we can run one more command just to check now what exact process is going on. So this is the command journalctl -f -no -pager. So here you will see one particular process install disk, this one. So if you see, once this particular process completes, the machine will reboot. 46%. So it will definitely take few more minutes maybe, and I can bring up the virtual machine screen as well here so we can see that whenever it gets rebooted. Okay, now if you see bootstrap completed, your system will reboot now. So let's wait for it to reboot. Okay, so now virtual machine is rebooted, and after this virtual machine boots up, another process will run RPM OS3, basically uh, like performing some of the important stuff for the cluster to come up. But right now our SSH will fail due to some security issue to this machine, because what will happen, earlier when we did SSH to the machine, uh, it was running as a live operating system, I should say, and now the machine will be booting up with the hard drive, like where the operating system is right now installed. So that's why those SSH related signatures and all are changed. That's why it will give the warning. So for that, what I will do, I will quickly modify my known host file on the MacBook, and I will remove the entries for that SNO machine IP address. Okay. After that, okay, machine is up. Let's SSH again. I will say yes here. Let's become the root user, and I will run the same journalctl command to verify what actually is going on. Okay. So if you see, particularly is trying to pull this particular image right now. So this process will also take a good amount of time. Once this complete, the machine will again reboot, and after that all the necessary containers, like basically the control plane, the router port, like everything will start coming up one by one for the cluster to become ready. So yeah, even if you see on the VM console, you can see RPM tree system management daemon. So it's performing the processes right now. Okay, so now the virtual machine is restarted again, and we will wait for it to come up. So yeah, see, it booted from the hard drive. Okay, once it comes up, we can again try to SSH into it. Okay, let's try to SSH into it. Okay, we are inside the virtual machine, and let's start the journalctl command. Yeah, so it's asking me the password because this virtual machine is now connecting to internet for pulling the images, so I have given the permission. So yeah, it's waiting for API and everything. Now everything will start coming up one by one. Okay, so one more thing we need to perform on our MacBook. So inside that OCP directory, there is a auth directory again and containing a kubeconfig file. So if we see the contents of this file, so basically this kubeconfig is like this kubeconfig file can be used to access your cluster, like run the OC commands without performing any OC login. So here if you notice, our request will be going to this api.ayush.example.com. Okay, so basically when we run OC commands, our request will go to this URL, and it should be resolvable to that virtual machine IP address of our SNO cluster. And from our MacBook, if we try to look up this, it is not working right now. So maybe what we can do, we can verify the host file if it is there or not. Let me type the password. Okay, some typo. Let me give it another try. Yeah, so api.example.com is there, and my bad, ns lookup will not work because what basically it is doing, the ns lookup always send the dns query to your name servers, and for etc host it doesn't get considered ideally in case of ns lookup. But if you try to curl or send any request to this url, it will be able to resolve to the url, like resolve to the ip address because of that etc host entry that we have done here already. So yeah, if you see, the request has been sent to 131. So now to access our OCP cluster, what we need to do, we need to export that particular kubeconfig file. So first of all, let me get the path. This is the path. Export kubeconfig equals to path of that file, and the OC binary is also here. We can try to run OC get command. So yeah, one of the operator is up, which is cloud credential, and the network operator is coming up. So eventually the whole cluster will come up. So we need to just wait maybe for 30 to 35 minutes because it definitely takes a lot of time. Whole cluster is up now, and we can try to access the OCP web console as well. So before doing that, we need to make the entries for these two routes, the console route for accessing the web console, and for the OAuth route where we will be providing our OCP user credentials. So we have to edit the etc host file, and we will make the entry for both of these routes, and it will point to the same SNO cluster VMI address. Okay, so now let's try to access our OCP web console. Yes, it's accessible, and we have to just accept the self-sign certificate for console route, and we have to accept it for the OAuth route as well. And now, yeah, asking for the password, and we can give it from this particular file, kubeadmin password. So the username will remain the same, kubeadmin, and the password is this one. Not now, I don't want to set the password right now. So yeah, everything is up like cluster control plane operators, so dynamic plugins, and these are like what I should say, like maybe the optional part, not that much crucial. But yeah, at the end we managed to install the SNO cluster on top of M1 MacBook Pro as a virtual machine. So yeah, that was it.